Hey folks, so here is a chart that's going to be helpful for when you need to factor any polynomial. The first step that you always do is look for a greatest common factor. It's going to make it easier to factor. It's going to reduce the coefficients, the size of the numbers, and possibly the power or degree of the terms. And many of you, when we have a leading coefficient greater than 1, like the slide and divide method. And if you like the slide and divide method and you don't pull out a GCF when there is a GCF, the slide and divide method will not give you the correct answer. So if you like using this slick method, please always look for a GCF, and you should anyway because it makes the problem easier. So that's step number 1. From there, how you use this chart, and if you don't have this chart, you should design one that looks similar to it. You can just copy it, but you can print one off. It's in the Module 9 folder in Canvas. Is after you look for a GCF, whether there is or is not a GCF, step number 2 is to ask yourself, how many terms are there? Sometimes there will be 2 terms. And if there's 2 terms, we're going to use this method that I'll touch on in a little bit. Many times there will be 3 terms. And if there's 3 terms, your leading coefficient, this didn't make the list. Your leading coefficient is called the A term, or the A value in a trinomial. If the A value is 1, which means it probably doesn't actually even appear as a number, it's an invisible one, then you use this easy diamond method. If your A value is greater than 1 though, and you can't factor that value out to make A equal 1, you got the old slide and divide method, you've got the split the middle method. If you're going into pre-calc, they're gonna really like you to try to be able to do the guess and check method. So that's addressing, what I highlighted in green is addressing if there's 3 terms, that's the way this chart's laid out. And then lastly, there is a potential to have 4 terms. And then we use this factor by grouping. Let's dive into these terms, or these methods for factoring based on the number of terms you have. So let's zoom in. If there are 2 terms, you're gonna see if it's the difference of squares. Notice there is a minus sign here, folks. If there are 2 terms, and you might be asking, well, Mr. P, what does that exactly mean if there's 2 terms? The number of terms are the number of things that are getting added or subtracted. So there's the 2 green terms, they are being subtracted. By the way, if you have a GCF, I'm just gonna make a quick polynomial here. This, I shouldn't have used those numbers, I suppose, but this blue highlighted 4 that I have right there is not a term, it's a GCF. How many things are being added and subtracted here? 2. There's 2 terms. Alrighty, so if there are 2 terms and they're being subtracted, and you realize that both of those terms are perfect squares, meaning they can be square rooted into just integers and variables, then you can do the difference of squares. So an example here would be 9x squared minus 16. I see 2 terms, they're being subtracted, and both of those terms can be square rooted. Once you figure out the square roots, which the square root of 9x squared is just 3x, and the square root of 16 is 4, you take those square roots and you add them, and you multiply that with those terms being subtracted. And it's important that the square root of the second term, the square root of 16, which is 4, goes in the second position. It's going to be a positive 4 in one of the parentheses or factors, and a negative 4 in the other parentheses or factor. And if you check it out, folks, this is correct. When you FOIL to check your factoring, that gives you 9x squared. This gives you negative 16. But remember, we need to do the smiley face check to get the middle term, which the middle term is missing here. When I do that multiplication, I get 12x. When I do the big smiley face check, I get negative 4 times 3x, which is negative 12x. These combine to 0x. That's why there is not any x's listed between the x squared and the constant term. So when you see 2 terms, your only hope for right now is difference of squares. Remember, last fall or winter we did learn the difference in sum of cubes, but I don't believe we're going to dive into that again. So what if you have 3 terms and you realize that the leading coefficient is 1? See that? There's an invisible 1 right there, folks. That is awesome. You celebrate that because this problem is so quick and easy. You're going to look for numbers that multiply to negative 12 because that minus sign makes the 12 negative, and add to 4. So we like you to make the diamond. It's not a diamond, Mr. P. It's an X. Yeah, make the X, whatever you want to call it. Look for numbers that multiply to negative 12. So you can pull out your factor chart, and that's the ways to multiply to 12. Of course, it's a negative 12, meaning one of each of these pairs needs to be negative. So you multiply to that. And when that happens, when one of them needs to be negative, you actually look for which pair of numbers have a difference of 4. It's that one, so it's going to be 2 and 6, but make one of them negative, and it needs to be the correct one. In this case, it's negative 2. And then remember, you just shove those behind the x's. And if you were to FOIL this thing back together again, you would truly get x squared. You'd truly get negative 12. And when you do the smiley face check and you multiply the x with the other number and the x with the number in the other factor, and you combine like terms, you get that 6x and the negative 2x, which make 4x. Pretty cool. I'm going to stop there and we'll dive into an a is greater than 1 in a second.